how's it going? This is Justin with Lesser Dog Tutorials, and this is the second video in the enemy section of the Retro FPS tutorial series in Unreal. And what we did in the first one was kind of just set up the enemy so that it can register being shot, and then the ability system component can kick into action and reduce his health. So in this one, we're going to be focusing on the AI and making the enemy kind of come to life. And we want our enemy to sort of act like the enemies do in the old retro FPS games. So there's a lot to do, and so we should probably just dive into it. What I have already done in preparation is I've created a new folder in the flipbooks folder called Pistol Enemy, and I put any sort of flipbook related to this pistol enemy in here. Next, what I did was I renamed all of the walking animations that we had. I renamed them FB underscore pistol enemy underscore walk underscore and then the direction. So once you've done that, then head over to the textures and start making a few other flipbooks. So the idle flipbooks are all just textures 32 through 39. I just created a new flipbook for each one of these, and I named it the direction, and I added idle in there. And then I created the shooting animation, or flipbook, which is just the texture number 40, because he's only ever going to shoot at the player, so it's going to be facing the player, and that's why I'm only using front. And then I created a damaged flipbook using number 80. And then I created a dying animation flipbook, which uses 88 through 114. And then I set the frames per second to be 8, so it's not so fast. And then I created a dead flipbook, which is the very last texture, number 115. And that should be all of the textures that we'll be using for flipbooks, at least in this video. So go ahead and make these flipbooks, and then you can continue on. The next thing I did was I opened the blueprint for the enemy, and for the walking animations, I added the word walk in front of them, and I added them to a category called walking within flipbooks. So the next thing I want to do is create some more flipbooks for the idle animations. So I'll just say idle front and make sure that that's a flipbook. And then I can just do a new one, idle front left, and we'll do each direction. And then I'll add these to their own category also. And then I'll go ahead and tick these eyeballs. And then we'll add a few more flipbooks. This will be for shooting. And another one for damaged. Another one for dying. And the last one for dead. And I'll just put these in the base category of flipbooks. Cool, now we can compile. Oh, actually, you know what? I'll click these eyeballs too. And in the BP pistol enemy over here in the flipbook section, we can just find all of the various flipbooks that we made and fill them in. So with the flipbooks all assigned in the pistol enemy, we can compile and save, and we'll head back over to the base class of the enemy. And what we want to do is change the flipbooks to be idle unless the enemy is moving, and then we'll switch it to the walking animations. So in order to get that going, we're going to want to create a enumeration. So I'll just do it in the blueprints folder for now, and we'll just choose in the blueprints section enumeration. And I'll call this enum enemy facing. And really, all that this is going to have is, let's see, it'd be front, front side, side, back side, and back. So front, side, side, back side, and back. That's all we need in this one. We don't need to determine which, if it's left or right. We just need to say if it's side, front, or back. And then back in the enemy, we can create a function called set flipbook. And what this will do is take in two inputs. Both are paper flipbooks. And the top one will be called walking, and the bottom one will be called idle. And all we really need to do for this is create a new Boolean called isWalking. We're just going to check if we are walking, and if we are, we use the walking animation, and if we're not, we use the idle. So all we're doing is we're setting the flipbook, and then we're doing that twice, depending on if this is false or true. And then if we are walking, we're using the walking. If we're idle, using the idle. And that's really all we're doing in this. And then in the set facing macro, instead of doing this, what we'll do instead is just remove all this. And for the input, we're going to remove one of these. And for the one that's left, we're just going to look for the enum enemy facing. And we'll call that facing. And then if you drag out from facing, we can do a switch on this enumeration, which will just determine what side we're passing in, and then change the flipbook accordingly. So really for each of these, we just have to do this set flipbook function and pass in the corresponding flipbook. So also for the output, I'm just going to remove this pin. We really don't need this pin, so we'll just go back to this. And then for the front, it doesn't matter which side we're actually facing. The front will always be the same. So we don't need to determine if the left side is visible for this one. So all we'll do is we'll find the flipbooks for walk front and for idle front. And we just pass these in here. And this is all we're doing. So we'll comment here and say front flipbook. And then we'll just move this out of the way a little bit. And then we need to determine what happens on the side. So for the side, we're actually wanting to branch. So we'll hold B and left click. And then we'll say, is left side visible? Because if it is, we got to determine which side we're doing. So if left side is visible, we're going to be setting the flipbook. And then we'll also be setting the flipbook if it's not visible. But we're just switching which flipbooks are being used. So walk front left and idle front left. And then walk front right and idle front right. So that is the front side flipbooks. And then we're just going to basically do the same thing that we do here for the side, back side, and then for the back, we're just doing this. So I'm going to speed through it real quick, and And remember, we're just determining whether or not the left side is visible to say which flipbook we're using here. So with that done, head back to make sure that these are working right. So now over in Calculate Flipbook, you'll see that this stuff doesn't really work anymore. So all we really need to do is delete these flipbook variables, and then we can actually determine what this is manually. So I'm just going to make things look nice and neat. All right, and so for this stuff, we want this to be front, this one to be front side, this one to be side, this one to be back side, and that one to be back. It's really as simple as that. And so if we compile and save, we can actually test this out and see how it looks. All right, so the enemy is now idle, which is what we're looking for. And so that is working well. So back in the blueprint for the enemy, what we want to do is separate these last two macros from the sprite face player, because we want to do a check to see if we should be changing the angle of the enemy. And really that should only be occurring if A, we want it to, or B, the enemy is not dead, because if the enemy's dead, he's just going to have that dead sprite and it's always going to face where the player is. So what we'll just do is add a couple of bools, and we'll say is dead, and then another bool called pause angle calculations. And we'll just test to see if either of these are true. So we'll use an OR Boolean. And then we'll just branch from this. And we'll say that if these are false, then we'll do the actual calculations. This will come into play later. And then one more thing I want to do in here is add another macro, and this will be called check if walking. And it's very simple. We're just going to add the two in and out exec pins. And then we will need to get the character movement, and then from that we'll get the velocity, and that should be at the very bottom, get velocity down here. And now that we have the velocity, we can get the vector length, and then from the vector length we'll just see if the return value is greater than 0. And then we'll branch from that. And then all we're doing is saying is walking is either true or false depending on the result. And so if it is greater than 0, we are walking. And that should be all we need to do to determine which animation the enemy should be using. So we'll just add this right after get enemy angle. And then once we determine if we're walking or not, we can then calculate which flipbook to use. And so that's all we'll be doing for the moment in this enemy blueprint. So the next thing I want to open up is the retro character. And what I want to do in here is determine what happens when the enemy loses all of its health. So in order to do that, we're going to create a function real quick. And we'll just call this health check. And what I want to do is add a return node. But I'm going to add another output, and this is going to be of the type Boolean. And I'll just call this is dead. And then what I can do is I'll make this function pure because I don't really need it to actually use these exec pins at all. And then I'm going to copy this, because all we're doing is checking to see if the return value is less than or equal to 0. And if that's the case, this character is dead. So back in the event graph, I'm going to just delete everything in the begin play. And then down here in the take damage, I'm actually going to change the instigator here, because for some reason it wasn't registering that in my tests. And instead, I'm going to take this effect context and get the instigator actor from that, and then put that into the instigator. This will come into play later, so I figure I might as well just fix that now, and we can move on. So after we report the damage, we will remove all of this also, and we're just going to do the health check, and we're going to branch from that. So that means we're testing to see if the character is dead, and if they are, what do we do? Well, let's create a custom event, and we'll just call this kill character. And then if the character is dead, we'll just run kill character. And that's all we need to do in this retro character blueprint, because we want to override this stuff in any sort of character that derives from this. So speaking of that, let's head back over to the enemy. So in the enemy blueprint, I'm going to just remove these nodes, and I'm going to, over here on the override section, I'm going to look for the kill character, but I'm also going to look for take damage. So now that we have these, the take damage and kill character, we can add a call to the parent function for these, because we still want to do what's on the parent function, and I'll do it for kill character as well. Even though we don't have anything in there for kill character, it's better to do it just in case we add something later that we want to be used in every inheriting class. So for the taking damage, the first thing we want to do is see if this character's dead. If it's dead, we shouldn't be doing anything. However, if it is not dead, we do want to continue. So what we'll do if the character is not dead is we will set pause angle calculations to true. And then what we want to do is take this enemy flipbook component, we'll set the flipbook to be equal to, and remember he's taking damage, so we want the damaged flipbook. And then from that we will, from the enemy, we'll get the flipbook length, and then delay. And then from that, we will set the pause angle calculations back to false. So temporarily, we're just going to, if like the character could be walking away and you shoot him, we want to stop the angle calculations, because when we play the damaged flipbook, it'll be facing the player. So now that that is done, we can do the kill character section. And the thing we want to do first for this is set is dead to true. And then we're going to get the capsule component, and we're going to set collision enabled, because we don't want to run into the character anymore, so we're going to say it has no collision anymore. And then again, we're going to set the flipbook. We're going to basically do what we did up there, because we want to run, instead of the damaged, we want to run the dying footbook. And then when that's done, we're essentially just setting the footbook again to be dead. And there you go. Those are the two functions we need to put in before we can try to test this out. And so let's test it out, see what happens if we kill the enemy. Shoot him once and he faces me. It goes really fast, but he does it. And I'll shoot him one more time. This should kill him. And now he's dead. And so if you rotate around, you'll see that the dead sprite is going to always be facing you. And if you walk through it, you're not going to be hindered by it. And then if we test it again, just to see what happens if you're walking into the enemy, it's stopping me. I shoot once, he moves a little bit, I shoot again, and now I can walk through him. So you could have enemies blocking your path in a hallway or something, and then killing them is the only way to get through. So let's fix the footbook, because for the footbook for when he's damaged, we can actually extend the time just a smidge. I'm going to do 3 total frames, and I'll save that. And then if I hit play, and I shoot him, now he faces me for a little longer, and it looks a little more natural. Okay, cool. Now that we have that kind of stuff figured out, let us focus on getting the character to move around and have artificial intelligence. In order to get AI working, we need just a couple things off the bat. So in the enemies folder, I'm just going to create a new folder that I'll call AI. And then in this folder, I'm going to go up to artificial intelligence here, and I'm going to create a behavior tree. And I'm going to call this BT underscore pistol enemy. Then I want to go back into creating a new object, and I'm going to go to artificial intelligence again. And this time I'm going to select Blackboard, and I'll call this BB underscore enemy. And then I'm just going to open up the behavior tree for the enemy. And over here in the details panel, you'll see, if you bring down this behavior tree dropdown, you'll see that the BB enemy is selected. And if it's not, just find the BB enemy Blackboard, because that's what we'll be using. Next, what I want to do is create a simple random patrol situation going on in here, so that the enemy will just kind of walk around randomly, and we'll at least give him some life and see how it works. So from the root, if you drag down from the bottom here, we'll just find a selector node, and this will mainly come into play in a little bit, but for now we're just going to select one tree here, and this is going to be a sequence, which means that it's going to run whatever's under it left to right. And so the first one we'll do is a move to. And then after that, we're going to look for something called wait. So essentially we need to find, right here at the beginning, we need to find a position to move to, and then we'll move to it, and then we'll wait a few seconds, and then we'll go back to find another position, move to it again, and wait. And that's basically what we're wanting to do. So the first thing we need to do in order to get this find random position is we actually have to create a new task, and that's what these are called. These are called tasks. So if we create a new task, it will open it up, and we'll just head back to the main window because we want to rename this. And we'll just rename it BT task underscore random location. And now the one that's been opened will be renamed, and then we can use this to find a random location. However, there are a couple things we need to do in here first. So when we are moving to, it says move to : self actor. We don't want to move to an actor or the self actor. We want to move to a location. So up in the right side, you'll see a little Blackboard tab, and you click that, and you'll see there are keys here. And they're just variables, essentially. So we only have one, it's self-actor, and it's of the type actor. So let's create a new key, and this will be a vector. And this will be called target location. And with that done, we can save it, head back to the behavior tree, and we'll select this move to task. And over here on the Blackboard key, instead of self actor, we can choose target location. So essentially that just means we're moving to this target location. And then we want to wait 5 seconds, but let's throw in a random deviation of 1. So that it's not always 5 seconds. It could be 4, it could be 4.8, it could be 5.7, or whatever. And so now that we have this new task, we can actually just put it in here and search for a random location. And now that that is in there, we can rename it. So over here in the node name, I'm just going to rename it to get random location. But I'm going to spell it right. Okay, so now we have kind of the random patrol set up in the actual behavior tree. We just have to figure out the logic of get random location. So if you open that up, then we'll just do a few simple things here. And over in the functions, you'll see there's 6 overridable functions. We can hit that drop down and we'll do event receive execute AI. So with that, we want to drag out from the controlled pawn. So this would be the enemy. And we're going to get the actor's location. So now we have a reference to where the actor is. And then from this return value, we're going to get random reachable point in a specific radius that we say. And so the radius right here, we'll just say that the radius is 500. So it's going to be getting a random point that it can walk in within 500 units and then walk to that. So then we say, the return value will say branch from that. So we'll determine if we actually received a reachable point. And if we did, then what we'll be doing is setting the target location to be equal to the point we get here. So in order to actually do that, we'll need to create a variable, and we'll call this patrol location. And the type cannot be a vector or anything like that. It needs to be a Blackboard key selector because it's just going to select a key based on whatever we pass in here. And that's kind of what you have to do for all variables in these tasks, is they always need to be Blackboard key selectors if you're wanting to specifically alter a key on the Blackboard. So also the second thing you need to do is make sure that this variable is public by clicking that I. It's very important. Otherwise it won't actually show up. Now you can drag in this patrol location, and from it, if you do set Blackboard value, you'll see that you can set bools or classes, enums or floats or objects or whatever. And so we're doing the vector because that's the location value. So if this is true and we found a spot, we can say the random location is the new patrol location. So then what happens if we don't get a return value? Well, we'll just do the actor's location as normal. So now that that has been completed, we just got to hook up the patrol location here. And I'm going to clean this up a smidge. And then I want to run a node called finish execute. And then we will check success. It has been successfully executed. And really, that's all there is to it for this. So now with this done, we need to say what this patrol location actually changes. So if we go over to the actual behavior tree, we can see here that the patrol location is set to self actor. We don't want that. We want to set it to target location. So make sure you select this task, and then up here in the patrol location, we can just set that to target location. And then we need to do another thing in here, and we'll create a blueprint class, and this will be of the type AI controller. Because now we need to say specifically that the enemy has a specific controller that we can use. So I'll call this BP underscore retro FPS enemy AI. And so now that we have that, we can open up the enemy blueprint. And in here, we can look for the AI controller class. And instead of AI controller, we'll do our new BP retro FPS enemy AI. Next, I want to create a variable that is of the type behavior tree. So I'm going to call it behavior tree. And then we got to make sure that we find that type, because we need to be able to set this per enemy. And so I'm going to add in the begin play event. And then we're going to get the controller. And then from this, we'll cast to the retro FPS enemy AI. And then from this, we will run behavior tree. And the behavior tree we're running, you guessed it, this variable here. So that should be all I believe that we need to do, other than making sure that this guy has the behavior tree. So let's open up the pistol enemy, and then we'll look for the behavior tree variable right here. And we'll just select our pistol enemy behavior tree. After that has been compiled and saved, we need to look in the Place Actors tab and find the nav mesh bounds volume and drag that into the scene. And you can see if you just drag it in as is, there's a little green section that just shows where AI can walk. So we just have to switch to top here, and we'll try to center this. And then we can change the scale of it to encompass the whole room. And I believe the scale for this is 12 by 12, yeah. So if you switch back to perspective, you can see the entire room is now green. And now what I'm going to do is move the player start to be a little bit farther away. And then I'm going to turn it to face this enemy. And now before I test it, what I'm going to do is go to the flipbooks and the pistol enemy flipbooks. I'm going to select everything, I guess that's not walking. So let me just select this stuff here, and I'm going to edit via property, bulk edit via property matrix. And then I'm just going to change the material to be equal to our new sprite material so that it is affected by lights. And I'll save all. And then what I want to do is change the actual speed of this enemy. So I'm going to select the pistol enemy blueprint, because other enemies may have different speeds. So then I'm going to look for the walk speed. And I'm going to change it from 600 to 250. All right, let's test this out and watch the enemy walk around, and hopefully it works. There he goes. He just picked a random position and he walked to it. Now he's waiting, and now he moved again. And it looks like it's working. Let me shoot him down as he's moving around, and yeah, everything works well. He does seem a little dark. Why don't we change the material to be a little brighter? So for the multiply node, I'm going to change it from 0.25 to be 0.5. See how that looks. Yeah, that looks a little better, a little easier to see. Yeah, I like that. Cool. Now let's get this AI a little more complicated and see what we can do. Let's open up the behavior tree again, and we're going to add a few nodes in here. The first one we will do is a selector, and this selector we'll rename to in combat. So a selector will choose either that we're in combat or this sequence here, which we will call random patrol. So either we're in combat or doing a random patrol. And a selector will choose two states over here. The first one will be a sequence. Actually, they'll both be sequences. So I'll have two sequences. And the first one will be called attack sequence. And the second one will be called move into position. That's essentially what we're doing. So we just have to figure out the logic for these, and then we'll be finished. So for the attack sequence, we want to first face the target, right? And we're just going to put the nodes out and then specify after specifically what we're facing and all the other variables. The next one is a wait. We're going to wait. But for this one, we're going to only wait 0.5 seconds with a deviation of 0.25. So it's going to wait briefly. And then we're going to do a ranged attack. And there is no task for this, so we'll make a new one. And it's going to be based on the blueprint base. And we'll just go back real quick and rename this new one. Oops, that's the random location. We'll rename this new one. Ranged attack. And then we'll just leave that for now. And then we'll just call it here, ranged attack. And I'm going to rename it to ranged attack. Okay, so we rotate to face the enemy or the player. We wait briefly. We do a ranged attack. And then we get the random location again. And this is the same task as this one. And I'll just rename that again to get random location. And then lastly, we will move to that location. So that's pretty simple for the actual attack sequence. Face the enemy, wait a second, attack, get a new location, move to it, face the enemy, wait, attack, and over again. And then for the move into position, if we ever lose sight of the player, we're going to come over to the move into position, where we will first run an EQS query, which we'll get into in a bit. And that is just an environmental query system query. So essentially what the enemy will be doing is looking around the environment for something specific. And once it's found, then the enemy will move to the location found and then face the player again. So we do the rotate to face blackboard entry, and we'll say face player is what this one's called. And run EQS query, we're going to rename this to find player. So now that we have just the general nodes figured out, let's get into specifically how this stuff will work. So let's start with the in combat node. How do we know if the enemy can see a player? Well, why don't we add, if you right click, we can add something called a decorator, and we'll select the very top one called blackboard. And what it says now is blackboard based condition. So we can check over here in the blackboard, if one of these keys equals a specific outcome, then we can say, okay, we are in combat, let's do this stuff. In order to do that, we'll just select this blackboard based condition, and over here we can say the query is set, and which key are we looking at? Self actor. But we kind of want a reference to the player, and then we can say if that player has been found or is set, then this can actually fire and we can do this stuff. So let's make a new blackboard key, and it will be an object. It'll be just like self actor, but we're going to call it target actor. We're going to say target actor because maybe later we'll want it to be another enemy as opposed to just the player. Now, in order for this to actually work, we need to go over here to the key type under object, and the base class will want to switch to actor. So you can see it here. So with that done, we can save it and head back over to the behavior tree, and we'll say self actor set is not what we want. We want target actor. So target actor is set. That's the condition we're looking for. Also, we could say observer aborts up here. With this selected, you can see observer aborts, and we want to choose lower priority. And what that means, I believe, is that also when you select it, you'll see that the stuff to the right of this will be light blue. And that essentially means all stuff to the right of any node is going to be lower priority. So if we're going through the random patrol, we get a random location we're moving to, and then all of a sudden we see this target actor and that becomes set, we abort it. And then we go straight over here and we do everything we need to do over here. So now that we know we're in combat, the target actor is set, which we will figure out in a bit how that becomes set. But right now, we're just seeing what the AI should be doing based on certain keys. So target actor is set, we're in combat. Now it's going to go to the attack sequence because that's on the left side, so it's going to go left to right. And the attack sequence will first say, face the enemy or the player. And I want to rename this actually to face player. Or actually target, because like I said, it might not be the player. In order to determine if we are doing an attack sequence or a move into position, we have to figure out if we have a line of sight to the player. That's the determiner to decide which node to go to. So we can do the same thing on attack sequence. We can add another blackboard based condition decorator, and we'll call that can see target. Okay, so now we say, okay, if we can see the target, that's good. That's what we want. But the blackboard self-actor is not what we're looking for. We want like a bool maybe. So let's go to blackboard and create a bool. And we'll call that can see target. And then we'll save that again, switch back over to the behavior tree, and then we'll select the can see target. And if it is set, meaning it is true, then we have seen the target or we see the target so we can move on. So we also want to say observer aborts lower priority again, because if we're moving into position and then we can see the target, stop moving into position and let's just face the target, wait, shoot them, and then start moving around and get another position. Cool, so we did the actual requirements to do these things. And so now there's a few of these that need to be worked out. So facing the target, we need to say we're not facing the self actor, we're facing the target actor. We're going to wait, that's fine. A ranged attack we'll fill out in a second. We're going to get a random location, and it's not the self actor, we're getting the target location. It's the same thing we did over here. And then we're moving to not the self actor, but again, the target location. Then over here in the move to position, we find the player. And finding the player is not going to be the self actor. It's actually going to be the target location, meaning we need to know where the player is located, not who the player is. So maybe I'll just rename this to find player location, or find player location. And this specifically is going to be the player. It's not going to be a target. And I'll show you in a bit why that's the case. And then we're going to move to, and it's not the self actor, we're moving to the target location. And then we're facing the player, but that also should be target, because that will work on the actual target actor. So we're facing the target actor. All right, so that is all we need to do for the behavior tree, but we need to fill out, I think, one more task here, and that's just the ranged attack. Otherwise, we then need to decide what EQS query we're running. So the first thing we want to do is do this ranged attack, and let's fill this out real quick. And so if you recall, we want to override the receive execute AI. We're going to get that controlled pawn. We're going to cast to the enemy. And then we're going to want to run an event on the enemy that would be its attack. So let's head over to the enemy blueprint here. And we're just going to add a couple of custom events. First one we'll say is melee attack. And the other one is a ranged attack. And then for the ranged attack, why don't we just do a print string and we'll just say ranged attack. And that way we'll know that it's firing. Okay, so back in here, we want to run that ranged attack. And then after that's done, we finish execute. And we make sure to check the success. All right, so that's simple. We can elaborate on what the damage is later, but for now, we just want to make sure the AI behavior tree is working. So now let's get into what the EQS system does and how to get it working. So the first thing we'll need for the environment query is let's go to Blueprint class and we'll search for env query context blueprint base. So it's right here. We'll select that. We'll just call it EQC underscore player context. And this is not that complicated. All we're going to do in here is override provide single actor. And we're just getting the player character. And then that's what we return as the resulting actor. And that's really all we're doing in this. Very simple. So now we want to add in the artificial intelligence section an environment query. And we'll call this EQS underscore find player. If you open that up, it looks a lot like an AI behavior tree. And all we're going to be doing is not that much. We're going to be looking for a grid. So we're going to do a points grid, which creates a grid around the enemy. And this basically creates kind of a grid of nodes that helps the AI search the environment. So for the grid half size, we're going to do 800. And for the space between, we'll do 300. And to show you kind of what this is doing, let's go ahead and create a blueprint class, and we'll search for EQS testing pawn. And if you select that, it doesn't really need to be named anything. We're going to delete it in a second. I'll just call it BP test pawn. And if you throw that out there, and I'm going to hit P to hide the green floor, then what this is going to do is kind of show you the query system that it's using. So when you assign, if you scroll down and you see the EQS section, the query template, we'll just add the find player. And then you can see kind of the nodes that it's going to use. And so if we were to change this, from 800 down to like 400, you'd see that the grid shrinks in size. And if we change the space between to something like 150, you'll see that it increases the amount of nodes. And you can play around with this for whatever you need. But for our purposes, I'm just going to do 800 for the grid half size and 300 for space between. Something that takes up kind of a largish area, but doesn't have a ton of nodes. So now that you can kind of see how that works, we don't need this testing pawn anymore, and you can delete that. And you could even, if you want, delete the test pawn, which I will do. All right, so back in the environment query find player, I want to add a couple of things to this. And they are both going to be tests. So the first test I'm going to add is a trace. We're going to switch this to filter only. And then for the context, we're going to find the player context. And then I think we want to turn off bool match. Next, we're going to add another test. And this one will be distance. So for the distance, we want it to be score only. And for the scoring factor, we're going to do -1. And you can read more about what this stuff does. There's a link in the description, which is close to what we're following. And it kind of breaks down all the different steps, and it helps kind of explain the purpose of these tests, in addition to the environment query system in general. So I'll save that, and now I think we're done for this section. So we can head back over to the behavior tree, and then for this find player location, we can do the EQS find player here in the request, and I believe that should be all that we need. Okay, so with this done, the only other thing is that we need a way for the target actor to be set on the NPC so that we know that we can switch to a combat scenario. So I went ahead and I opened the Retro FPS enemy AI that we made earlier, and I'm going to add a component to it. So I'm going to search for AI perception. And so when you add this, we add basically a way for the AI to perceive something. So if we go over here to the right side, when we have the AI perception selected, there's a census config array with 0 elements, and we'll add 2. For the first one, I'm going to go down and select the site config. And for the second one, I'm going to do the AI damage sense config. And then if you were to select the drop-down for these, you can open up a section called Sense. There's a section called Detection by Affiliation under the site config. If you drop that down, it will say Detect Enemies, Detect Neutrals, and Detect Friendlies. We want to make sure that not only is Detect Enemies true, but also let's tick the box for Detect Neutrals also. So with those done, now the enemy will visually sense something, and then it will also sense something based on receiving damage. So if you open the BP FPS player, we can also add another component, and this time we want the AI perception stimuli source, because now the player will become a source of perception, while the enemy AI will be the perceiver of the source. With the perception stimuli source selected, we're just going to click the auto register as source, and then right below it, it says register as source for senses. We'll add 2. We're adding the site, and we're adding damage. So now the AI can sense us visually, and then it will sense us if we cause damage to the AI. Now before we leave, let's click the class defaults, and we're going to search for tags. And under actor, there'll be an array of tags, and we want to add one element to this, and we're just going to say player is the tag that we're adding to this. And this will be used in the AI to sense and make sure that the object it's sensing is the player. So we're using this tag to determine that. Back in the event graph of the AI, we can delete these nodes, we won't need them. And if you select the AI perception down here on the right side in the details, you'll see these events. And we want to override the target perception updated. So it's right here on target perception updated. So once that has been added, this stimulus source, we can right click and split that because we need to use this bool here. So the first thing we'll do is that we want to right-click the actor, and we'll promote that to a variable. And we'll call this perceived actor. So then we can drag out from the perceived actor, and we're going to see if it has a tag, specifically the tag we made previously. So we'll just type in player, and then the return value we will branch. So now we know that the perceived stimuli source is our player. And if that's the case, we next want to see if the stimulus is successfully sensed. So we'll add a little reroute node here, and then we'll branch again. So if the enemy perceives this actor and the actor has the tag of player, and we successfully sense it, then what we'll want to do is update the blackboard and say that the target player or target actor is equal to the player. So in order to do that, we will create a new function, and we'll just call this update site key. And in here, it's going to be relatively simple. All we're going to do is right-click and get the blackboard, which gets a reference to the blackboard we made. And then from the return value, we'll set a value as a bool, and we can hook that up. And really all we're going to be doing is say that the bool is either true or false based on whether or not the AI can see the player. So for the input, we'll just add a boolean, and we'll just say has line of sight. And then we can connect that up to the bool value. As for the key name, we need the actual name of the key verbatim in the blackboard. So if we open up the behavior tree and switch over to the blackboard, we have this can see target. So that's the phrase we're going to be using. So back in the AI, we can do a make literal name, which will the return value will be passed into the key name, and we'll just type in can see target, and it needs to be exactly the same spelling and capitalization and everything as the key in the blackboard. So with that done, we can actually duplicate this because the other key that we want to update is the target key. So for the target key, instead of has line of sight being a boolean, we want to make this an actor. We'll switch that to an actor, and instead of has line of sight, we'll say this is the target actor. Okay, so when you link it back up, it's not going to work because it's the bool, so we don't need the set value as bool, we need the set value as object. So now you can hook up the object value to the target actor and then the key name to the make literal name. We just need to switch it to the actual name, which is, if we check again, I already know what it is, but we'll check to be sure. It's target actor. So let's rename this to target actor. So now we have the two functions we need to update the keys accordingly. So back in the event graph, we can say, okay, the AI has perceived the actor who is a player, and we are successfully sensing the player. Let's update both of these. First one we will update is the sight key. So we can say true, has line of sight. Tick that box. And then we will update the target. When the target is updated, the target actor is the perceived actor we made earlier. There you go. Now, if we successfully see the player, we will update both the keys. We have line of sight, and we can see the target. However, if this is false, and we have already seen the player, however, we no longer can sense them, meaning they're either outside of the AI's line of sight, or they're not causing damage, the player's not damaging the AI anymore, then we need to run a timer to count down the amount of time that passes that the AI cannot see the player, so that when the timer runs out, then the NPC or AI enemy can reset and go back to wandering around aimlessly. So if we set the timer by event when it's false, then we could say, how long is this timer? We'll say it's 8 seconds, and then we'll create a custom event here, and we'll call this lost sight. And we'll just hook that event up to this. And so if we have lost sight, we need to update the target key. So we'll copy that and paste it, and we won't pass in any actor because now we will reset it so that the target actor is null. So now we want to take this return value, and we'll right click that and we'll promote that to a variable, and we'll call this lost sight timer because we want to be able to cancel this. And in order to cancel it, we can actually just drag these out. We'll take a reference to the lost sight timer, and then we will clear an invalidate timer by handle. Then we can just plug this in between these, so it will reset the timer if we see the player again. And then right after this, we want to update the sight key so that we no longer have line of sight. So you can copy and paste and make sure that has line of sight is false. And that should be everything that we need. We have everything set if we see the player, and if we don't, we remove line of sight. We have a timer countdown, and then we lose the target actor if we never see the actor again. All right, so why don't we test it out and see if this works? Let's tweak some stuff in here a little bit first, and let's just copy a wall, and we'll switch the view to top. And we'll just kind of create a little barrier, and I might even move the player start down here in the corner. And then I'll rotate him so he's facing this way. And then I'll just take this new copied wall, and I'll just create kind of a little area where the NPC cannot see me. And then I'll just add another one spaced out a little bit so I can kind of hide a little bit. And then I think I'm also going to take the weapon pickup and kind of move it right here so that I can use this gun to alert the enemy to me. So let's test it out and see how it works. I'm going to grab that gun and I'm going to look and see where the enemy is. He does not see me, which is good. Let's see how line of sight. Oh, he just turned around and he saw me. So now he sees me. He's hitting me with his gun. He's doing a ranged attack and he's moving. He's doing another ranged attack. And then I could hit him and kill him, which is perfect. So let's see now if the damage will alert him to my presence. I shoot him once. Oh, he sees me and he's doing ranged attacks. So both of the AI stimuli perception sources are working, and he is doing his attacks, which is great. However, now let's see what happens if we hide from him and he uses that environment query system to find line of sight to me. So I'm going to hide behind this column here, and he should appear either on the left side or the right side, and he went right there. He found line of sight to me using the environment query system, and he started shooting me. I'm going to try it again. I'm going to get real close this time, see how it works. And he found me. He came right around the corner to find me. Cool. So that's going to do it for this episode. We've successfully implemented an enemy, and he is perceiving me, and he's attacking me, and he's reacting to me. As you can see, ranged attacks are still occurring, so there is a few more things we'll need to do to finish out how the enemy AI works. But for now, we have a pretty good skeleton for enemies in our game. So thank you for watching. If you liked the video, please hit like, please subscribe, and I'll see you in the next one.